Let's talk about the second assignment. In the first assignment, you were asked to, given a problem statement, come up with a UML class diagram, right? So to represent it formally using various classes and associations and various cardinality, and whether they were inheritance, whether they were one-to-many, many-to-many, and reify it and remove any redundancies and inconsistencies. In this case, we're already giving you the UML class diagram, right? So somebody has already gone through the process of interpreting some problem statements, right? And they've come up with this UML class diagram. Not necessarily the best, right? Somebody thought this was a great idea. And so this might be a generic version of what you were asked to do in the previous assignment. In the previous assignment, you were at the problem statement was about a content management system specifically for learning, online learning, right? Where faculty and students, right, they could create assignments and online content and whatnot. Here, this is a little more generic. It's a content management system in general, not specific to any particular vertical. And so you have a couple of types of users. You have the developers who can create all sorts of websites and websites that can contain many pages. Pages can contain many widgets. And they can drag and drop these widgets onto a page. And so there are many types of widgets that they can put on a page. There's some could be HTML widgets, heading widgets, images, YouTube images, YouTube videos, and whatnot. Now there could be an owner of the developer can be an owner of a website, but you could have many developers that are working on the same website, right? That could have different roles, right? Some of them can be administrators, some can be reviewers, some of them could have different roles, right? And different roles come with various privileges, right? So if you're an admin, then presumably you have all privileges, right? You can create, you can delete, you can update. You can view anything, right? But if you are a reviewer, perhaps you have some limited capabilities, right? Maybe you can write, but you can't destroy. You can't remove something. Maybe you can edit. You can view. So here we have a map, right? That sets the different roles of various developers in a particular website or in a particular page. Right, so you can be very granular, right? You can give them by the whole website or a particular granularity to a particular page. You can also be given specific privileges. You can create, you can delete, you can update, you can view. Different privileges. What else? Let's see. We have a couple of inheritance associations here. We have that developers and users can both be persons. They can inherit all the attributes of a person. So all developers or users have first name, last names, usernames, and whatnot. They also have, everyone has a phone, everybody has multiple phones, multiple addresses. Notice that this has aggregate and composite. It has a composition association, right? Meaning that the life cycle of the phones and the addresses depends on the life cycle of the person. Right? If I remove the person, all the other ones are cascaded and removed as well, right? Whereas here we have an aggregate relationship, right, where we have a developer has many websites, but if the developer goes away, the website doesn't go away, right? So there's no lifespan dependency on there. We do have a couple compositions here, right? If I remove the page, all the widgets go away, right? If I remove the website, all the pages go away, right? So there's some lifespan relationship there. We have a couple more inheritance associations here. We have a widget and that is a base class to a couple of other widgets, YouTube, image, HTML, heading. They all inherit these common features such as name, width, height, class, style, and whatnot, right? And then they all have their own specific attributes. All right. What else do we have here? We have a couple of enumerated data types, right? We have roles and privileges. Right, a developer could be given a particular role: owner, admin, writer, editor, reviewer, and these roles are somehow associated with privileges. Right, so if you're an owner or an admin, you can do all four. Right, if you're a reviewer, you can just read. Okay? And there's a table down below that specifies that business logic. Okay. All right. Let's see, what else? I think that's it. There's a couple of one-to-manys, right? One-to-manys everywhere. Other than that, let's see. All right. So one of the requirements that we're asking you to do is that you're going to be creating a remote database, right? Either on Heroku or AWS, your choice. We give you instructions for both, right? On how to fairly hand-holding instructions on how to set up databases remotely. You can choose whichever you want. Whichever you choose, you connect to it using some client, local client, either Workbench or SQLite or whatever you choose. Here we have instructions for doing it through Workbench, MySQL Workbench. And what you're going to do is that you're going to, as part of the deliverables, you're going to provide the connection string, right, that you need to connect to that database. That connection string should include the username, the password, right, and the host, the URL, and if the port, if it's different than the default port, right. The TAs, what they'll do is that they'll create a connection onto your database, right, and verify that everything's okay. Make sense? All right, so definitely we need a connection string. We're also going to ask from you an SQL file, a single SQL file that's going to implement what the assignment is going to ask you to do. All right? So one of the things that it'll ask you to do is create tables, do a whole bunch of inserts, create views, create a couple of triggers, do a whole bunch of inserts, updates, deletes, a whole bunch of selects. Right? So you'll have in one single SQL file, right, you'll have everything that has to set up your database. Right? You know, one of the first things that you're going to do is ask to drop all the tables. Right? So you start brand new with nothing. Right? And then part of that SQL file is you'll set up the tables. Right? There will be create statements. Right? That will create the tables. Right? Yes? Well, if it allows you to create two schemas, that's fine. Many of the free versions only allow you one schema, right? So it depends. If it allows you, that's fine. I don't mind. Also, the schema that will generate probably will be some random name, some GUID, which is fine, right? You just need to provide us with that connection string. All right. So anyway, I was saying that the SQL file will drop all the tables, will drop all the views, will drop all the triggers, will recreate the tables, will recreate the views, will recreate the triggers, right? And then it will do all the inserts, it will do all the selects, will do all the updates, all the deletes, everything that it needs to do in the order in which we're asking you to do it. Right? So what the TAs are going to do is they're going to connect to your database, and for each question, they're going to copy a part of that SQL script, right? And they're going to copy and paste it right on your database, right? And they're going to run it, execute it, see if it does what it's supposed to do, right? And then they'll move on to the next question, right? They'll copy from that one SQL file, and they'll continue grading as they go. That make sense? Okay. We ask you to please name the tables a particular way. We ask you that you use these variable names, right? These table names, these views that have to have a particular name, right? The triggers have to have a particular name, right? So that the TAs can follow along and grade you appropriately. So the first part gives you steps on how to set up a remote database using Heroku. First, it'll ask you to set up in a development environment. Right, so that make sure that you have Heroku installed locally on your machine, that you're logged in, that you have an account, that you have Java, that you have Maven, that you've created a simple Spring Boot application, which I believe you've already done that, and that it's running remotely on your Heroku or AWS, and then the next couple of slides or steps walk you through adding a remote database to that running application, right? And that database is the one that you're going to give us access to. Make sense? All right. You might want to do all your work on a local database, right? So you're not especially if you're using AWS, you might be wasting some hours or time. I don't know if you're using a paid account or not. If you're using Heroku, typically it will be completely free, if you stay within certain limits, right? But typically you might want to do all your work locally on your local instance of MySQL or your database running locally. Once you feel confident, you can then go and then test this remotely on the remote database. Okay? All right? And then, but give us the one that you know works remotely, right? So that we can then go on and try it out in your remote database. These are some preliminary steps that summarize. But if you want to look at the specific steps, you need to go in and visit these slides that walk you through the various steps in detail. Okay? There's also steps to do it for AWS, whichever you prefer. That's fine. AWS is just a slightly more involved, right? A little more challenging, but nevertheless, it's worth it. All right, so the first 15 points, we ask you to create a couple of tables, right? All the tables for all the classes that have been provided for you, right? So the first couple of points, we ask you to create a remote database, right? No points for that. So you create the database, and you're going to provide for us what the URL and the OIP address, username, password, and the login to be able to log into your database. For 5 points, we ask you to create the person, the developer, and the user, right, tables. And there's an inheritance relationship between them, right? Notice that person is the base class, right, and you have user and developer inheriting from it. Yes? As I mentioned earlier, there's 3 strategies for implementing inheritance. Here we ask you to use one of the strategies. We ask you to use the normalized strategy. Right? The normalized strategy splits up each class splits it up into its dedicated table. Right? So there will be a person table, there will be a user table, there will be a developer table. Right? And the primary keys of the person table will be referenced by foreign keys of the person, of the developer, and the user table. Those foreign keys in these user and developer table, there will also be primary keys, right? So there will be a one-to-one relationship of every record in the person table with every record in the user or the developer table. All right, make sense? That's called the normalized strategy. Okay. We also ask you to call the foreign keys, give it a specific name. Which will be the name of the subclass, name of the superclass, and then generalization, right? Meaning it would be something like developer, person, generalization, or user, developer. User, person, generalization. So name the constraints using using that naming convention. Then. For another 5 points, we ask you to implement this other inheritance between widgets, image, YouTube, heading, and HTML. Okay? In this case, we're asking you to use a different strategy. We're asking you to use the denormalized strategy. Right? And the denormalized strategy, instead of splitting it up into multiple tables for every single class, you just have one big table. Right? One big table, it's called denormalized. Right, we have just one big widget table, and there are no YouTube table or image table or HTML table. There's just one big widget table, right? And what we do is that we collapse all the attributes of the separate classes. We collapse them all onto the widget table. So, for instance, we'll do this more detail later. Well, what happens here is that all the attributes of YouTube, image, HTML, and heading, they're all added to the widget class. Okay? And we add an additional field called the D type. Right? So every record, whenever we insert a YouTube record, we would insert values for the widget plus all the values for the YouTube record. But all the other ones would be null. Right? The source would be null. The HTML would be null, the size would be null, Right? So the record, one single record, can represent either a YouTube widget, an image widget, an HTML widget, or a heading widget. Right? And so to be able to distinguish which one was it originally, right, we added an additional column. And that column typically has a name, something like type or dtype or something, right? To be able to remember, right? What was it? What was the original type of this record? Make sense? That's called the denormalized strategy. There's a third strategy. We'll talk about that a little later. Right? We'll cover a little later. And for another 5 points, we ask you to implement all the other stuff. Right? Such as we ask you to create the enumeration, the phones and the address, and the one-to-many between all this over here, right? All the roles and whatnot in between. For the enumeration and the role specifically, we ask you not to use the enum data type. Some databases support the enum data type, right? But not all databases support enum data types, right? So that if you use the enum implementation, then your database is not portable, right? You can't move your SQL from MySQL and move it over to Oracle or some other place that do not support enum, right? So we ask you to use what is called the portable enumeration strategy, right? A portable implementation of enumerations, which we'll introduce perhaps later today. Right? So do not use the enum. Excuse me. Okay. Any questions so far? All right. So for the first 15 points, create the schema. All right. For another 15 points, we ask you to create a trigger. Right? A trigger is a function that can be executed every time a particular event occurs. Right? And in particular, what we're going to be listening for is every time there's an insert, right, into a particular table. Where there's an insert to a role table, what we're going to do is that we're also going to make inserts into the privileges table, right, to keep track and enforce the fact that if you're an admin, you have all these privileges. Right? If you are a reviewer, you only have these other privileges. Right? So to enforce those kind of logic, right, we're going to be using triggers to do that. Right? So we're going to implement two triggers. One is going to be listening for inserts into the website table, and the other one is going to be listening for inserts into the page table. Okay? When we insert into the website, roles, right, is going to insert into the privileges. Right? Whenever we insert into the roles for the page, it will insert privileges for the page, and following the following rules. If it's an owner role, you are given these privileges. If it's an admin, you're given the same privileges. If you're a writer, you're given a create, read, and update, but no delete. If you're an editor, you're given read and update, but no create and no delete. If you're given a reviewer, you're only giving a read privilege. Make sense? All right. All right, so 15 points for the triggers. Once you have the triggers, we're going to do a couple of inserts. We're going to do a whole bunch of inserts. First, we're going to populate the developers and the users. Right? There's going to be 3 developers and 2 users. Okay? So they're going to be, you're going to have Alice and Bob, Charlie, Dan, Ed, A, B, C, D, E. And they're going to have these specific IDs. Please use these IDs, right, so that the TAs can then follow and make sure that these are the users. And you're welcome to use these IDs in later questions, right? So that if you ask, hey, retrieve all the websites by Alice, you can use Alice's ID. Okay? All right. Let's see, what else? All right, so we're going to populate the developer and the user table. That means that if you're inserting into the developer table, because you're using the normalized strategy, you're also going to be inserting into the person table, right? Because there's 2 tables. Same thing for the user. You're going to be inserting into the user table, but at the same time, you're going to be inserting into the person table. And the primary key and foreign key need to be the same. Right? Because they point, there's a one-to-one relationship between the 2. Okay. All right. After that, you're going to be you're going to be populating the websites table. Right? You're going to be creating several websites, 6 websites: Facebook, Twitter, Wikipedia, CNN, CNET, and Gizmodo. All right. With these descriptions, these names, but also relationships between different developers that are associated to those websites. Right. These are the IDs of the websites, and these are the various developers that are associated to that particular website. We have Alice, has an association with Facebook, and she's the owner. Right, so has a particular role. That means it's going to have a whole bunch of privileges. Right, so you're going to be inserting into the role table, which is going to trigger inserts into the privileges table. Right? Right. Same thing here. When we insert Bob as an editor, right, and we create the relationship, and we insert as a role of Bob, it's going to insert a whole bunch of privileges for Bob. Make sense? Right? And Charlie and whatnot. Okay? What else? So that's 3 points for that. Then you're going to insert into the pages table. For a particular website. So for CNET, CNET would be the one that has the ID 567. Right? We're going to create a landing page, a home, and the description is a landing page. And again, there's going to be an editor, a reviewer, a writer, right, and the number of views for that particular page. And these are the IDs for the particular pages. So about, contact, preferences, profile for the various websites. Make sense? Once you have that, we're going to create a whole bunch of widgets. And we're going to have now for the widgets, we're going to be implementing the denormalized implementation for inheritance, right? And that means that each record, right, each widget is going to have just one record, right? And then it's going to have a specific type, and the type is going to be right here. This is the type, right? That's the D type that you're going to populate to know what was the original type of that widget. Now, some of the fields will be null, plus some of the fields will have values such as text and whatnot. And notice that some of these values are null, some of the values actually have values, depending on the type and whatnot. All right. And plus, finally, we will have inserts into the phones and the addresses table. Right? So these folks will have multiple addresses, multiple phones. Okay. All right. For 10 points, we're asking you to implement a view. A view, as we'll see a little later today, is a named query. Is a query that you've been using quite along, right? You've been joining tables here and there, using complex predicates, retrieving records from here, records from there, joining them together, making fairly complex queries. And you found yourself that this is a very useful query, right? I'd like to be able to reuse it, right? So what you could do is create a view and give it a name so that you can then reuse it later on. So we're asking you to create a view that joins 3 tables. Joins the developer table, joins the website table, and joins the pages table, right? And retrieves fields for each one of those tables. Retrieving the following fields: the developer's first name, last name used in an email, a website's name, number of visits, and the last time that it was updated. The developer's role. Oh, okay. So you're going to be joining a couple more things. You're going to be joining also the role and the privileges table. Okay. You're going to bring the roles of in the website and the privileges for that website, and same thing for the page information and some roles and privileges for the pages. So you're going to be joining like 5 different tables, right? So it'll be a huge join. So give it a name, right? We're asking you to give it this name: developers, roles, and privileges. Then once you've inserted and whatnot, there's data in there, and you have a view, you can start now querying it. We're asking you to do some really trivial queries. Retrieve all developers. That's trivial, right? Select star from developers. You're done. And they become progressively more challenging, right, as you go. So this retrieve developers with whose ID is 34, which should be Charlie, maybe, hopefully. Retrieve all developers who have a particular role in a particular website. Retrieve all developers who have reviewers with pages that have less than so many visits. Okay. So for these, you'll need to do some joins. You'll need to do some grouping. You'll need to do some aggregation, right? And count how many there are, or averages, or mins, or max. You'll need to calculate a couple things. Then same thing for queries for websites, pages, and widgets. And also to verify that the triggers worked, right? That every time you were inserting a role, there were some privileges that were being added. There's some queries that we're asking you to do, right? Finally, you implement a couple of updates. You're going to update a developer, update Charlie's primary phone number, update the relative order of the widgets, right? So you can move them around. You can move widgets around, move them, drag them around. You have to move them also in the database, or change the name of an existing page, or change the roles, swap the roles of two developers. And also a couple of deletes. So the deliverables will be that you're going to have to provide us with a text file on your GitHub repository. Right? Remember, there's a GitHub repository we created for everybody. Right? There's a file there called submission.txt, right, for this assignment. In there, you're going to provide us information with the host name, the whole connection string, username, password, the URL, IP address, or the port number for your connection string, right? And we'll also be something that is not listed here. Something that we'll need also is the SQL file, right? That implements the drops all the tables, drops all the views, right? Drops all the triggers, recreates the table, does all the inserts. Right, does all the updates, all the selects from where the TAs are going to copy and paste on your database. Okay? All right, we'll need that as well. All right, we'll add it as a deliverable, but just so you know. All right. Any question?